All right, so this video is going to cover this chapter 14 recursion practice quiz number 3. So this quiz is probably not what you're going to see on any of the tests or AP tests, but it gives you kind of a little bit more, it's not like the hard chug and plug problem. So, all right, one, it says, which of the following statements about recursion are true? Every recursive algorithm can be written iteratively. That's true. So you can write recursion as a for loop or a while loop. 2, tail recursion is always used in divide and conquer algorithms. Divide and conquer algorithms are like the merge sort, which I demonstrated back in the array chapter. Excuse me. The tail recursion is when the final instruction is a recursive call, so 2 is not true. But tail recursion has nothing to do with divide and conquer. 3, in a recursive definition, the object is defined in terms of a simpler case of itself. So that is true because remember the physical analogy of like those Russian dolls? You're trying to find a base case. Sorry, let me get rid of that. You're trying to, like drill down into your base case, the most simplest case of, your recursion, and then often you gotta, pop back up the stack and go to to finish up your recursive call. So yeah, that's 3 is true. So it's trying to find the simplest case of itself. So 1 and 3 are correct. So your answer there is D. 2, which of the following, when used as the body of method sum, will enable that method to compute 1 plus 2 plus, all the numbers in between n correctly for any n is greater than 0. Okay, so 1 would be an infinite loop, right? Because there's no if statement that would end this. It wouldn't be like if, n is greater than, 0, or in the later on these ones, n equals 0. At least it ends with a return of 1. This one just goes, n is 5, and then 4, then 3, then 2, then 1, then 0, then -1. So it never stops. It just calls itself over and over and over again. 2, if n is 1, the return's 1, and then we do this over. Yep, so 2 works. 3, the only difference between 3, you've got this is the same here, and then here and here, else we've got, okay, so this would be an infinite loop similar to 1 here. This is fine because it's subtracting 1 out each time, but look at this. Let's say n is 5. This side of, and you'd have to write this out, but this side of the sum recursive call never gets subtracted down so that n would ever equal 1. So if n is 5 here, it would just call sum and pass in 5 up here. And then it would go down as n equal to 1. No, so then it would call sum 5 again. So 5 would be passed in. And it would do this over and over and over again. So 1 and 3 are incorrect. The only one that works is 2 is B. 3, refer to the method string recur. When will the method string recur terminate without error? Well, this is also an infinite loop. This says if the string's length is less than 15, then it just prints that. Else, it just does recur, and then, it adds up whatever s is and adds a star onto the end. So it just would do this over and over and over and over and over again. And if it's less than 15, it would print, but, each time you're adding 1 to it. There's nothing to get you out of that string recursion. So E no string inputs work because you just have an infinite loop. 4, refer to the method this. So if it's less than 15, then it would do this. Now this would add up each time. But if it's greater than 15, then it would just end the method and it'd be done. So when will the method terminate without error? For all string inputs. This is fine. In this one, if it's less than, it runs it. And if it's greater than, it doesn't run this at all, and that's what would end the recursive method, and you'd be done. Okay. 5 refer to the so 5 and 6, and yeah, I demonstrate that below. So 5, you've got so 5, I just threw in, so 5 gets called. So first time through, you call this, n is 5, so 5 minus 1. You know, what do you got? 2 times 16. What do you got here? 2 times the result, n minus 1. So which, calls 4. 2 times result, 4 minus 1 is 3. 2 times result, 3 minus 1 becomes 2. And then 2 minus 1 is 1. 1 is equal to 1, so it's 2. So 2 gets thrown in up here. That becomes 4. 2 times 2 is 4. Then 2 times 4 is 8. And then 2 times 8 is 16. 2 times 16 is 32. So this would be the first time you call it for, so 5, I guess, sorry. So 5 is B, right? Yeah, 32, what I got. And what do we have here? I think C, 6 is just asking how many times. If n is greater than 0, how many times will the result be called to evaluate? All right. So it evaluates 1, 2, 3, 4, 5 times, right? So if n is 5, and it repeats 5 times, then your answer for 6 is C. So n times. 7, refer to the method mystery. All right, so we pass in 3, 2, and 6, and that's 3, 2, and 6. And I've got that written out down here too. So 3, 2, and 6. N is not equal to 1, so we do 6 plus mystery, 3 minus 1, 2, 6. So that becomes 2. That's 2, and that's 6. Is n equal to 0? No. So we got 2 minus 1. So that gets passed in down here. So we return A. A is 2. Or this is 2. So 6 plus 2 is 8. And then we take the 8 and put it into this calculation. So 6 plus 8 is 14. So 7 is B. So fairly easy quiz, but gives you some more practice. So this video is done.